Hi there, Miss Marsh here. So in this video, we're going to look at the difference between parallel lines and perpendicular lines. We're going to define them. We're going to sketch pictures of them. We're going to talk about the different geometric notation that we use for them. And we're going to compare we're going to see how their slopes compare. And then we're going to do an example of writing an equation given a parallel or perpendicular line and a point. All right, so let's start with the definition. Parallel lines do not intersect. So there are two lines that never intersect. That's what most people think of as the definition. They're also the same distance apart, and they will never intersect. So how do we draw that? Let's use a straight edge and draw a line. And we know lines have arrows, go on forever. And probably the easiest way for me to do this in a computer program, which is not super fair because you guys can't do it, is I can copy and paste. And it's going in the same direction. And then from there, let me just fix my lines. No, don't move it. Haha, that would defeat the purpose. Okay, I'm just gonna draw in now I could do it. Get some arrows. There we go. We also say that they have the same distance apart. So if you were to draw a perpendicular line, well, we haven't talked about perpendicular yet, but a line that goes at a right angle to measure the distance, it would be the same distance no matter where you look, as long as you're going at the right angle. So speaking of perpendicular, let's define it. I pretty much just defined it right there. It's two lines that intersect at a right angle, which is a 90-degree angle. Okay, so if we draw a line, it can't just be that they intersect. This is not perpendicular. So I need to make them go like that, where I now have a right angle. I don't know why that little piece right there is there. Let's see if I can get rid of it. It's just a glitch, just ignore it. Okay, so we have one line and another line, and they meet at 90 degrees. Just ignore that. So those are perpendicular lines. So let's go and talk about the geometric notation. So we need to talk about the name of the lines. We can use different points like AB. So we can say that this is a line AB. And so and this one we'll call CD. And in the space between them, I'm going to draw two parallel lines. That is the symbol for parallel lines. Now for the other one, I'm going to use the different notation where we have a lowercase not capital, but italic, like lowercase letter to the other side, so like L and M. And for this, I'm going to name lines L and M, but the symbol I'm going to put in is an upside down T. This is what means perpendicular. So upside down capital T shape is going to be perpendicular. The two lines is parallel. So when we're talking about slope, if we're graphing this in the coordinate plane, how do the slopes compare? Well, for parallel, they're going to be going in the same direction. And the slope essentially determines that direction. So how do the slopes compare? The slopes will be exactly the same. They are the same. Easy to remember. Same direction, same slope. For perpendicular lines, it's a little bit more tricky. The slopes are obviously not going to be the same. They're going to be different. they're going to be negative reciprocals or opposite reciprocals. So the word opposite means, in this context, different sign. So positive or negative. Reciprocal means to flip it over. So this, we're going to need an example. Let's say we have a slope of 2/3. A perpendicular slope, we're going to flip it over and change the sign. So this is a positive 2/3. So it's going to be a -3/2. Those are going to be perpendicular slopes. Okay, so then if we're dealing with the coordinate plane, we need to know how to write equations of lines that are either parallel or perpendicular to a line and pass through a given point. Okay, so it's helpful to see a graph of this to understand what's going on and what we're looking for. Okay, so for our first one, we have the line y equals 1/2 x plus 9. So just as a review, this is in slope-intercept form. The 1/2 is the slope, and the 9 is your y-intercept. So you can see that it crosses the y-axis at that point. And you can see that it's rising 1, running 2, up 1 over 2, up 1 over 2. That's your slope. Okay, so going back to our problem here, we're trying to write the equation of a line that is parallel to y equals 1/2 x plus 9 and passes through the point -8, 5. Okay, so if we go ahead and type in that point on the next line, we have a problem. That point goes through the line. So let's change it, because this doesn't make any sense, does it? Let's make it -8, 7. Just change it. Not a big deal. Because we can't make a parallel line that goes through that point, because the point, the line already goes through the point. So interesting error to think about. So let's make it -8, 7. So now it's not a point on the line. Okay, so I want you to imagine that there's a line that is parallel, so it goes the exact same direction as this line and goes through that point. What is the equation of that line? Well, you can kind of imagine it's going to go through some sort of part on the y-axis, but one thing we know for sure is we know what the slope is. Okay, so we know the slope is going to be 1/2. I'm basically stealing the slope from that line. Since they're parallel, they have the same slope. Okay. Now, one way to figure out the rest of the equation is to use the point-slope form. Okay, the point-slope form, or sometimes called the point-slope formula, because it's kind of like a formula, is the one that goes y minus y1 equals m times x minus x1. And we're going to substitute in there the slope, which is m, right here. And then we're going to plug in the point, the one that we fixed, with x1 and y1. So the -8 is actually the x1. And the 7, let me change the color here. Is the y1. So we're going to substitute everything in there. Okay, so it's going to be y minus 7 equals 1/2 times x minus -8. Remember, when you're plugging things in that have a minus sign in the formula, but you're plugging in a negative, you got to have both negatives, because what's going to happen here is that's going to turn into a positive 8. Now, if we want it into slope-intercept form, y equals mx plus b form, we're going to have to do a little rearranging. We're going to have to distribute. One half times x is 1/2 x, and 1/2 times 8 is 4. It's half of 8. And then we're going to move the -7 by adding 7 to both sides. And we get our answer is y equals 1/2 x plus 11. Okay, so we can verify that by graphing it. Y equals 1/2 x plus 11. Look at that. It went straight through that point. It is obviously parallel because we have a slope of 1/2. Awesome. Okay, now let's do this problem, but let's make it perpendicular. Okay, so we're going to write the equation of a line that is perpendicular to y equals 1/2 x plus 9, same line, and passes through the point 5, -3. So let's visualize that. Let's get rid of this line and this point. We have a new point, 5, -3, okay? And so imagine perpendicular. Remember, they have to intersect at a right angle. Kind of imagine what that's going to look like. Okay? All right, so now to do the math. The visualization is helpful, but you still have to do it algebraically to be accurate. Eyeballing where you think it's going to go is usually not going to give you the right answer, or rarely is. It is possible, but I highly recommend doing it algebraically. Okay, so in this case, our slope is not going to be 1/2. Our slope is going to be the opposite reciprocal of 1/2. So if we take 1/2 and flip it over, you get 2/1. And since it's positive, we need to make ours negative. This is -2/1, or you can just say -2, because dividing by 1 is not necessary. You don't have to write that. Okay, then I'm going to use that point slope form again with my new point and my new slope. So my slope was the -2, not the 1/2 this time. My x1 was 5, and my y1 is -3. Okay, we're going to substitute those three things and then rearrange it, simplify it a bit. Okay, y minus -3 equals -2 times x minus 5. Okay, so substituted everything in. And then I'm going to distribute and then get it into slope-intercept form. So I'll start by distributing. That's -2 times x, just -2x, and -2 times -5. A negative times a negative is a positive, so it'll be +10. On the other side, these two negatives are going to turn into a plus. And then from there, I'm going to just get rid of this 3 by subtracting it. Okay, let's plug it into the grapher and Desmos and see what it looks like. So we got y equals -2x plus 7. And you can see clearly it does go through this point, 5, -3. And although we can't measure the angle, we can, it looks like it's going to be 90 degrees. It's intersecting at a right angle. All right, I hope this video was helpful for you.